Now that we've made our unit circles, we are going to start looking into the logic of how we can use our unit circles to do things with mental math quickly. So we want to find the exact value of the following. We're going to state the reference angle and the quadrant, then the exact value. So when we're trying to find sine of 7 pi over 6, the key things to helping you find this is in your head you're going to say, I know that my reference angle is pi over 6. And if I know my reference angle is pi over 6, I'm going to think of my first quadrant. Pi over 6, what's my y-coordinate? Because sine is my y-coordinate. It's 1/2. So I already know that sine of 7 pi over 6 is going to be a half. I just don't know if it's positive or negative. The next thing I'm going to think about is what quadrant is 7 pi over 6 in? It's in quadrant 3. So because I know that sine of pi over 6 is a half, and because this is in quadrant 3, mental math, I'll know that sine of 7 pi over 6 is negative a half. So you know if you know the first quadrant on your unit circle, then you can use that first quadrant to find any other answer. The quadrant will just tell you whether it's positive or negative, and that's going to be thinking about your cast rule, and in quadrant 3, only tangent is positive. So sine will be negative. So here's our mental math. Tan of 2 pi over 3. What family does that belong to? What's your reference angle? Pi over 3. This is why radians are really nice, because you can find a reference angle so fast. Right? In degrees, you have to do more math to find the reference angle. In radians, reference angle super fast. What quadrant is 2 pi over 3 in? It's in quadrant 2. So if I know that tan of pi over 3 is root 3, but it's in quadrant 2 where tan is negative, tan of 2 pi over 3 will be negative root 3. Seven pi over 4. Reference angle? Pi over 4. Super easy to find the reference angle. What quadrant is 7 pi over 4 in? Quadrant 4. So, cos of pi over 4 is root 2 over 2. In quadrant 4, is cos positive or negative? Positive. We're done. Root 2 over 2. Secant, negative pi over 4. Well, reference angle will still be pi over 4. Now the angle is going in the negative direction. So we're thinking quadrant 4. But our unit circle doesn't have secant or cosecant or cotangent. So if we're trying to figure out secant of negative pi over 4, which is secant is the reciprocal of cos. So we'll first figure out cos of negative pi over 4. Well, we've got all the information here. Pi over 4 family for cos is root 2 over 2. Quadrant 4, cos is positive. So secant of negative pi over 4 will be 2 over root 2. Do you remember when we did our special triangle that root 2 over 2 was the same as 1 over root 2? And if I had 1 over root 2 and did the reciprocal, I'd get root 2 over 1. So on a multiple choice question, usually that answer for D would be written as root 2 instead of 2 over root 2. Can you see another way? If you did get 2 over root 2, and that wasn't one of the answers, if you rationalize the denominator by multiplying by root 2 and root 2. Can you see that that's equal to 2 root 2 divided by 2? And then your 2's would simplify to just give you root 2. So again, in grade 12, they assume you know how to do that. And on multiple choice, they'll check that. But on a regular answer, you could leave your answer as 2 over root 2 perfectly fine. Cotangent, negative 11 pi over 6. The easy thing, what's your reference angle? Pi over 6. You know that that's part of your pi over 6 family. What quadrant is negative 11 pi over 6 in? Okay. Quadrant 1. I'll give you a little bit of how I think about this and see if you like this logic of thinking. If you were thinking about positive 11 pi over 6, would you agree that that's in quadrant 4? If you go to quadrant 4 in the negative direction, 1, 2, 3, 4. Can you see that quadrant 4 in the negative direction is really quadrant 1? So that's sort of the logic. When I'm thinking of negative angles, I think about going the same number I would in the negative direction that I would go in the positive direction. And then I'd say, oh, that's the same as quadrant 1. Now, cotangent isn't something that we know, but you could figure out tangent of negative 11 pi over 6. Well, I know that tangent of pi over 6, 3 plus 3 is 6, is root 3 over 3. It's in quadrant 1 where it's positive. So cotangent of negative 11 pi over 6 will be 3 over root 3, which happens to be the same as root 3. And finally, F, we've got pi over 2. What quadrant? Well, first of all, what's your reference angle for pi over 2? That one's a little bit different because it's not one of our ones that we've had. Okay? How do we find a reference angle? Think about pi over 2. We go to the nearest x-axis. Oh my goodness. Which one's closer? Positive x-axis or negative x-axis? They're the same. So your reference angle, this way is 90 degrees, this way is 90 degrees, this way is pi over 2, this way is pi over 2. Your reference angle is pi over 2. Okay? It's in between. We can't really say it's in a quadrant though, right? Is it quadrant 1 or is it quadrant 2? It's not. It's like right in between them. Can't really say it's in either. We can either say it's in both of them or it's in between them and it's neither of them. It depends on where does one quadrant start and where does the next quadrant end. So we're going to have a little bit of trouble here, but, okay, cosecant, the reciprocal is sine. Oh, sorry. Negative pi over 2 wouldn't be at the top, right? Negative pi over 2 would be there at the bottom. Same problem, though. We don't know if it's in quadrant 4 or quadrant 3. But if you did sine of negative pi over 2, if you think about your unit circle, what is the coordinates down here? 0, negative 1. So for anything that's on your axis family, you'll probably just use the coordinates. And sine is which value, the x or the y? The y. So sine of negative pi over 2 is equal to negative 1. That means cosecant of negative pi over 2 will be 1 over negative 1, which is still negative 1. So these first ones that we did here were all straightforward because they dealt with one time around the circle. What we're going to do at the beginning of class next day is look at ones that are past one time around the circle. And this is where we'll start tomorrow.